So oftentimes, when it comes to working with limits, we'll use a graph. We'll look at a graph and determine what the limit is, or sometimes we'll use numerical methods, figure out what the limit is. But what we end up doing most of the time in a calculus course is evaluating limits analytically. For example, we might have a limit like this. The limit as x goes to 2 of x squared. Something like that. Now, it's easy. You could use graphical methods, you could use numerical methods, but it's pretty easy to see that this limit is 4. And you can see here it's just a matter of plugging in. Actually, if you just plug in a 2 in here in this x, in for x, you get what the limit is. Likewise, you might have something like this. You might have the limit as x goes to 2 of something else, x plus 1. Well, 2 plus 1, that's going to be 3. This is just a line. And so this limit would be 3. So these are examples of evaluating a limit analytically. We didn't have to use a graph or anything. We could just plug right in. And that's the thing with polynomials and a lot of other functions. You can just plug in and get the limit. Now, you can't always, but a lot of times you can. Now, let's suppose, let's just break this down a little bit. And let's suppose that we've got f of x is equal to x squared. And let's suppose that g of x is equal to x plus 1. And we know, we've just seen that the limit as x goes to 2 of f of x, we've just discovered that that's 4. And the limit as x goes to 2 for g of x is, of course, 3. But what would happen? What if we put these two together? In other words, what happens if we see a situation like this where we have x goes to 2 of f of x plus g of x? That type of situation. In other words, what happens if we've got this? The limit as x goes to 2 of, let's see here, we've got x squared plus x plus 1. What if we had this limit to evaluate? How would we go about finding that limit? Well, notice that f and g are both just polynomials. When you put them together, you still have a polynomial. In a situation like this, you can just plug in the, plug in the function, or plug in the x value. So this would be 2 squared plus 2 plus 1. Yeah, like that. And this is going to be 4 plus 2, that's 6, 7. So you get a limit of 7, and notice that's 4 plus 3. Now let's take a minute and just look at this graphically and see what's going on here graphically. And then we're going to look at some other properties of limits here. But let's just take a minute and look at these. So let's see what this looks like graphically. What I've graphed here is the f of x, which is x squared. And you can see, yeah, pretty clear that the limit is 4. See, we got that right there. That's the limit. Limit is 4. Okay? Now, let me turn that one off and graph the g of x. And you can see that that limit is 3. Okay? So there's f of x and g of x. And, of course, we could put those together. But let's think about what would happen if we add the two functions, f of x and g of x. Let's see what happens here. We get this green function. And now let's see what the limit is here. We've got 2. So I come up here till I can find the limit. Right there it is. See that? There you go. 2, 7. See, that's f of x plus g of x. Because what you're doing, I mean, when you add these two functions, you're just adding the one value here, that value to this value down here. I can't ever read it on it. Whoops. There we go. I'm just adding this to this, and it goes up here. I mean, so it's pretty straightforward to see, looking at the graph that, yeah, if you have the sum of terms there, you can just evaluate each of the terms. So let's look at this a little more, and we'll look at some other properties. So let's just look generally then, and let me get away from this whole thing of f of x and g of x being defined specifically as particular functions, and let's just consider two functions here, or two general functions. Let's say x is going to a of f of x, and let's suppose that equals L, just some L, uppercase L. And let's suppose the limit as x goes to a of g of x, let's suppose that that's equal to some k. And what we want to do is I just want to go through here and just state some properties of limits. And really what this is, these properties, we're not going to explore them in any depth. This is just going to give us the authority to, for the most part, plug in and evaluate the limits that we have. So for example, here's what we have so far. We have the limit as x goes to a of f of x plus g of x. And let me do a minus on there too. It's plus or minus. Let's say I did the plus up here. Let's just say plus or minus. Well, that's going to be L plus or minus k. Now, another property that we could explore in more detail is this one. There is the product, f of x times g of x. And that would be Lk. In other words, the limit of the product is the same as the product of the limits. Okay. We could also look at this one, the limit as x goes to a of, let's say, f of x over g of x. And we've got to be careful when we have fractions like this, because, I mean, this is going to be L over k generally, provided that k does not equal 0, or not k does not equal 0, provided that, provided that k does not equal to 0. Yeah, provided that k does not equal to 0. So we have to be careful always, because we can't just take the limit of the top over the limit of the bottom if the limit of the bottom is going to be 0. So we got to really watch our bad selves there and not make that mistake. Now, we've also have situations like this where we have the limit as x goes to a of, let's suppose we've got a constant times f of x, like that, a constant times f of x. Well, that is just going to be the constant times L. Okay? In other words, it's the limit of, the constant is just something that can be pulled out, and then you evaluate the limit. We also have this, the limit as x goes to a, and let's just suppose we've got f of x to some power. Well, that's going to be L to that power. So these are some of the properties that that we can use to deal with problems like this. Let's suppose that we've got the limit as x goes to 5, and let me just make something up here, x squared plus 2x plus 1, and down here x plus 3. And we want to evaluate this limit. Well, this property right here enables us just to evaluate the limit of the top over the limit of the bottom, or in other words, we don't even have to think about that. We're just going to plug in. So I'm going to plug in here, and I get 5 squared plus 2 times 5 plus 1 over 5 plus 3. See, we're just plugging in. And this is going to give us 25 plus 10, 35, 36 over 8. Yeah, 36 over 8. And I guess that's going to be, well, 2 will go into 36 18 times. And 2 will go into that 4 times. And I guess that's going to be 9 halves. And that's going to be our limit there. So these are some of the properties that give us the authority to just plug in most of the time.